Okay, let's have a look here. So, alright, it's an inequality proof by induction. So firstly, we want to prove for case n equals 3, that's the first case. So 1 over 3 factorial, is that less than 1 over 2 power 2? Is 1 over 6 less than 1 over 4? So that's done. 2, we assume true for case n equals k, i.e. 1 over k factorial is less than 1 over 2 power k minus 1. And then step 3, we're required to prove that 1 over k plus 1 factorial is less than 1 over 2 power k plus 1 minus 1. So we have to prove this. So usually with these proof by induction inequalities, it's best to start from 2. So we have 1 over k factorial is less than 1 over 2 power k minus 1. And we want to get the lower side up, the left side up to the next case, I think. Isn't that usually it? So let's plan this. If I was to multiply both sides by 1 over k plus 1, that would become this here. Or actually, yeah. Which side do we want to get up? Let's see. Let me just think for a few seconds. It's a bit early. Yeah, no, I think that's the best thing to do. So if you were to multiply both sides by 1 over k plus 1, then the left-hand side would become 1 over k plus 1 factorial. And then the right-hand side would become 1 over k plus 1 times 2 power k minus 1. So now we're required to prove that 1 over k plus 1 times 2 power k minus 1 that's less than 1 over 2 power k. So the logic here is that we started with something we're assuming is true, and we've shown that this is true. So if we can now show that this is true, then we've shown that this guy is less than this guy here, which is exactly what we need. So all that's left to prove is this inequality. Okay. I think maybe because k has to be positive, because everything has to be positive here, I can rearrange this as follows. Probably want to expand. Or is that going to make things... No, actually, you know what? I could divide both sides by 2 power k, actually, so I can get 1 is less than k plus 1 times 2 power minus 1. Then I can multiply both sides by 2. And that's good. That's good because we know that this is true since k has to be bigger than 2. For these statements, the index is at least 3. Yeah, okay. So required to prove, and now it's proven. Required to prove. Yeah. Okay. Yeah, okay. Not too bad actually, not too bad. So the final step then is our logic step where we say 1 plus 2 plus 3 altogether means it's true for n equals 3, 4, 5, etc. Yeah. Just wondering now, because this was true, would this have been true if we started at 2? 1 over 2 factorial, is that less than or equal to 1 over 2? Less than... okay. This would have been true if you just make this an equal sign. Would have been true. 1 over 2 factorial less than or equal to 2 power 1. Yeah. I don't know why they did it that way without the equal sign. Made it a strict inequality. Oh well, doesn't really matter. Okay, that's the end of that one. I think that one's alright. Wasn't too bad.